Probability is a fundamental concept in mathematics, statistics, and many other fields. It describes the likelihood of an event occurring and essential for understanding and analyzing a wide range of phenomena, from weather patterns to financial markets. Here's the probability of three different events along with the formula used to calculate the probabilities. 1. Event. Tossing a pair coin and getting heads. Sample space. Heads or tails. Favorable outcomes. Heads. Probability calculation. The probability of an event is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. Formula. P event number of favorable outcomes or total number of possible outcomes. In this case, there is one favorable outcome. Getting heads out of two possible outcomes, heads or tails. Probability of getting heads equals 1/2 or 0.5. Number 2, event rolling a pair six-sided die and getting an event number. Sample space 1, 2, 3, 4, 5, 6. Favorable outcomes 2, 4, 6. Probability calculation. The probability of an event is calculated by dividing the number of the favorable outcomes by the total number of possible outcomes. Formula. P event equals number of favorable outcomes total number of possible outcomes. There are three favorable outcomes rolling A to 4 or 6 out of 6 possible outcomes. Probability of rolling an event equals 3, 3 over 6 or 1/2.
3. Event. Drawing a heart from a standard deck of 52 playing cards. Sample space. Ace of spades, 2 of spades, king of clubs, ace of hearts, king of hearts, king of diamonds. Favorable outcomes. Ace of hearts, 2 of hearts, king of hearts. Probability calculation. The probability of an event is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. Formula. P event equals number of favorable outcomes slash total number of possible outcomes. There are 13 favorable outcomes, 13 hearts out of 52 possible outcomes, 52 cards in a deck. Probability of drawing a heart equals 13 over 52 or 1 over 4.
Fundamental counting rules. The fundamental counting rules, also known as the multiplication principle, is the fundamental concept in combination that allows us to calculate the total number of possible outcomes for a sequence of independent events. This report will explore several examples of how the fundamental counting rule can be applied to solve real-world problems. Here's an example of report that demonstrate the use of the fundamental counting rules. Example number 1. Choosing a shirt, pants, and shoes. Suppose you have 5 different shirts, 4 different pairs of pants, and 3 different pairs of shoes in your wardrobe. How many different outfit combinations can you create? Using the fundamental counting rule, we can calculate the total number of possible outfit combinations as follows. Number of shirt choices 5. Number of pants choices 4. Number of shoes choosing 3. The total of the possible outfit combination is 60. Therefore, there are 2 different outfit combinations can be created from the given choices. Example number 2. Choosing the destination, transportation, trip duration, and number of people. Suppose you're planning a trip and need to make the following decision. Destination city 5 option. Mode of transportation is 3 option. Number of days for the trip 4 option. Number of people traveling 2 option.
Using the fundamental counting rule, we can calculate the total of possible trip plans as follows. Number of destination choices 5. Number of transportation choices 3. Number of trip duration then 4. Number of the people choices 2. Total number of possible trip plans equals 5 times 3 times 4 times 2 equals 120. Therefore, there are 120 different plans that can be created from the given choices. Example number 3, combination lock with 4 dials. Suppose you are creating a combination lock for a safe, and the lock has the following features: 4 dials, each with number from 0 to 9. Each dial can be set to any number from 0 to 9. Using the fundamental counting rule, we can calculate the total number of possible combinations as follows. Number of choices for each dial, 10 to 9. Total number of possible combinations equals 10 times 10 times 10 times 10 equals 10,000. There are Therefore there are different 10,000 possible combinations for this combination of kind of luck. The fundamental counting rule is the powerful tool for solving a wide range of combinatorics problems. By understanding that applying this principle, we can systemically calculate the total number of possible outcomes for a sequence of independent events, which is useful in various fields such as probability statistics and computer science.
The permutation rule is a combinatorial principle used to calculate the number of ways to arrange or order a set of objects. It is used when the order of the objects matters. Here's a permutation rule along with 3 examples and their corresponding formulas. The formula for the permutation rule is P equals n factorial divided by n minus r factorial, where P represents the number of permutation of r objects chosen from a set of n objects. N factorial denotes the factorial of n, which is the product of all positive integers from 1 to n. Now, let's look at the 3 examples that illustrate the application of the permutation rule. Example number 1. Arranging books on a shelf. Suppose you have 5 different books and you want to arrange them on a shelf. How many different arrangements are possible if you can't repeat the same arrangements? Rn is equals to 5, the number of books. R5, R is 5, number of positions on the shelf. Using the permutation rule formula, P equals 5 factorial divided by 5 minus 5 factorial equals 5 factorial divided by 0 factorial. So, bring down the 5 factorial divided by 1 factorial because not equal to 0. Hindi siya pwede maging 0. Kaya mabutangan na siya 1. 5 times 4 times 3 times 2 times 1. Kaya kutob rata sa 1 equals to 120. Therefore, there are 120 different arrangements possible for the 5 books on the shelf. Example number 2, selecting a committee. Suppose you need to form a committee of 3 people from a group of 10 individuals. How many different committees can be formed? Rn equals 10 number of individuals. R equals 3 number of committee members. Using the permutation rule formula, P equals 10 factorial divided by 10 minus 3 factorial. 10 factorial divided by 7 factorial. 10 minus 3 equals 7. Equals to 10 times 9 times 8 ay 7 man, 7 equals 720. Therefore, there are 720 different committees that can be formed from the group of 10 individuals. Example number 3, password combinations. Suppose you need to create a 4-digit password using the numbers 0 to 9. How many different password combinations are possible? R, oh, sorry. N equals 10 number of numbers. R equals 4 number of digits in the password. Using the permutation rule formula, P equals 10 factorial divided by 10 minus 4 factorial equals 10 factorial divided by 6 factorial equals 10 times 9 times 8 times 7 equals to 5,040. Therefore, there are 5,040 different password combinations possible using the number 0 to 9.
So the next topic is combination rule. The combination rule is a combinatorial principle used to calculate the number of ways to select a subset of objects from a larger set, where the order of selection does not matter. The formula for the combination rule is C open parenthesis and R close parenthesis equal to n factorial divided by R close parenthesis r factorial multiplied by n minus r factorial. So, natay problem anhi nga isa. So, ang problem is choosing lottery numbers. Suppose you need to choose 6 numbers from a pool of 49 numbers for a lottery ticket. How many different combination of numbers are possible? So, n is equals to 49 numbers in the pool and r is equals to 6 number of numbers to choose. So using the combination rule formula, C 49 and 6 equals to 49 factorial and divided by 6 factorial multiplied by 49 minus 6. So mo diri follow through ta sa ubos. So 49 divided by 6 factorial multiplied by 43. Then so nga rin na ta sa so mag-equal siya 43. So mo na diri follow through gyapon sa baba. So 49, 48, 47, 46, 45, 44 ato silang i-multiply tanan and ang niripon sa pika side ang 6 to 1 ato po sila i-multiply then ang result is atong i-divide. So muna ni diri nakita ng result. So ang result sa ato ang nga gi-multiply na to ang 49, 48, 47, 46, 45 and 44 nag-result siya sa 10,68,347,520. Then divided by 720. Ang 720 is gikan siya sa 6 times 5 times 4 times 3 times 2 and times 1. So kanin duha ato ni siyang i-divide. So, ang nag-result siya og 13,983,816. So, therefore, there are 13,983,816 different combination of 6 possible for the lottery ticket. So, this example demonstrate how to use the combination rule formula to calculate the number of possible combinations. By understanding this rule, we can determine the number of ways to select the subsets from larger sets.